pair of linear equations in two variables. In class 9 you have studied about linear equations in one variable and two variable. The general form of linear equation in two variable is ax plus by plus c equals 0, where a not equal 0, b not equal 0. Two linear equations which are in the same two variables can be represented as a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals 0, where a1, b1, a2, b2 all are not equal 0, where a1, b1, a2, b2 are also real numbers, and a1 square plus b1 square not equal 0, a2 square plus b2 square not equal 0. This is called a pair of linear equations in two variables. That is, the two linear equations occur simultaneously in same two variables. Now we can do a problem. Arab tell his daughter, 7 years ago I was 7 times as old as you. Where you were then. Also 3 years from now I shall be 3 times as old as you. You will be. Represent the situation both algebraically and graphically. Arab tell his daughter, 7 years ago I was 7 times as old as you were then. Also 3 years from now I shall be 3 times as old as you will be. Represent this situation both algebraically and graphically. This is an example for pair of two variables. Let Arab's age equals x years, that is present age. Arab's present age. Then Arab's daughter's present age equals y years. We can first represent in algebraic situation. First condition. From the question we are writing the algebraic situations. So first condition, x minus 7 equals 7 into y minus 7. Simplifying we get x minus 7 equals 7y minus 49. That is x minus 7y minus 7 plus 49 equals 0. That is x minus 7y plus 42 equals 0. This is first equation. Now we are taking second condition. Second condition, x plus 3 equals 3 into y plus 3. Simplifying we get x plus 3 equals 3y plus 9, or x minus 3y plus 3 minus 9 equals 0, or x minus 3y minus 6 equals 0. This is second condition equation. So these two equations, pair of straight lines, represent the two equations, x minus 7y plus 42 equals 0 according to first condition, x minus 3y minus 6 equals 0 according to second condition. Next we are taking graphical situation. Graphical situation, x minus 7y plus 42 equals 0. This is the first situation. Here we get x equals 7y minus 42. From here I am making a table for drawing graph. Put x equals For convenience, I am taking y. First, y equals 5. Substituting the value of y equals 5 here. In 1, we get x equals 7 into 5 minus 42 equals 35 minus 42 equals minus 7. So when y equals 5, I get x equals minus 7. Next put y equals 6. Y equals 6. Then I get the value of x as x equals 7 into 6 minus 42 equals 0. Next I am taking y equals 7. Then I get x equals 7 into 7 minus 42. 49 minus 42 equals 7. This is the first situations. Next, then the second equation was x minus 3y minus 6 equals 0. From this I get x equals 3y plus 6. Here also I am making a table. Put y equals 0. Then I get x equals 6. Y 0, x equals 6. So the point is 6, 0. Next, when y equals 3, we get x equals 3 into 3 plus 6 equals 15. So 15, 3. Then I can take y equals minus 2. Then I get x equals 3 into minus 2 plus 6 equals 0. So 0 minus 2. Here minus 7, 5. 0, 6, 7, 7. Using these tables, I can draw a graph. Using these two tables, we are drawing a graph. This is x-axis, x dash. This is y-axis. Here negative side y dash. I am taking maximum value of x is 15. Taking 2, 4, 6, 8, 10, 12, 14, 16 like that. Minus side also minus 2, minus 4, minus 6, minus 8 like that. Then here also 2, 4, 6, 8, 10, 12, 14 like that. Here minus 2, minus 4, minus 6, minus 8, minus 10. So plotting these points. First one minus 7, 5. Then 0, 6. Then 7, 7. Joining this. Next one also 6, 0. Then 15, 3. Then 0 minus 2. This goes like this. If this go extending, this will meet at any point. This is graphical representation. So we can represent the pair of two variables in algebraic form as well as graphical representation. Second problem, the coach of a cricket team buys 3 bats and 6 balls for rupees 3,900. Later, she buys another bat, and two more balls of the same kind for rupees 1300. Represent this situation. Both algebraic and graphical. Algebraic and graphical situation. The coach of a cricket team buys 3 bats and 6 balls for rupees 3900. Later she buys another bat and 2 more balls of the same kind for rupees 1300. Represent this situation both algebraic and graphical. Solution. Let cost of bat equals rupees 6 and cost of ball rupees y. First algebraic condition. First condition. 3x plus 6y equal 3900. And second condition. 1x plus 3y equals 1300. From this we write two algebraic situations. 3x plus 6y equals 3900. 1x plus 3y equals 1300. Next we are drawing the graphical situation. First condition 3x plus 6y equals 3900, from which we get 6y equals 3900 minus 3x, from which I get y equals 3900 minus 3x by 6, or then from this I can put the values and framing a table. If I put y equals 0, then I get x as or 3900 equals 3x, x equals 1300. If I put y equals 500, then I get 500 equals 3900 minus 3x by 6, or 3000 equals 3900 minus 3x, simplifying 3x equals 3900 minus 3000 equals 900, provided x equals 300. Similarly, when y equals 650, any value I can take, then 650 equals 3900 minus 3x by 6, cross multiplying, or 3x equals provided x equals 0. Then second table also I can frame. Then framing second table. The second equation I get x equals 1300 minus 3y. When I put y equals 0, then I get x equals 1300. Second, if I put y equals 500, then x equals minus 200. When I put y equals 300, x equals 400. From this we can draw a graphical representation. Maximum value of x is 1300. So take 200, 400, 600 like that. Here then for y, maximum value of y is 650. So first case 1300 0, then 300 500, then 650 0 650. So the graph goes like this. Second case 1300 0, then minus 200 500, then 400 300. So it goes like this. So it will meet at any point. So this is graphical representation.